So hello, everyone. Very happy to be here. Today, me and my colleague, Professor Ilzes Lokmanes, will tell you about a project that we've been working on together with our colleagues from the Artificial Intelligence Lab of University of Latvia's Institute of Mathematics and Computer Science. Can you see the slides?
Yes.
All right. So this is a project that we are very excited about. Namely, this project is centered around the creation of our own very own Latvian WordNet. Today, we will tell you about the project in general, as well as some of the key developments of the project so far, and what hopefully still lies in store for the project in the future. But before we jump to the Latvian WordNet specifically, some of you may have the completely normal and understandable question of what exactly is a WordNet. So first things first, a WordNet may seem like a very specific tool, but it can actually come in handy to all kinds of users, those who are very tech savvy as well as just normal language users. So in brief, a WordNet is a large lexical and semantic database, which consists of structured information on word meanings. And the main word groups that WordNets tend to concentrate on are nouns, verbs, adjectives, and adverbs. And in order to structure the information on word meanings, we use something that we call semantic links. So we cluster word meanings together, and then we connect them with semantic links to show all kinds of semantic relationships between these clusters of word meanings. So there are various types of semantic links that we use. First, we have synonymy links. With these, we connect word meanings that virtually mean the same thing. So for example, a building and an edifice are synonyms. And what happens when we link two synonyms with a synonymy link is that we create something that we call a synset, or a set of synonyms. And a synset is a very important unit in the general structure of the WordNet, and I will tell you about those in a minute. Next up, we have autonomy links, and with these, we link words that word meanings that are opposites. So, for example, big, small, or hot, cold. And we also use hyponymy links to show relationships between a broader category and smaller subtypes. So, for example, an oak is a type of tree, and hyponymy is great for translation. Because various languages and different cultures have different ways of classifying things. So a translator might have to opt for a broader or narrower category in order for the target text to sound as natural as possible. Next, we also have Meronomy links, and these show the relationship between a whole and its parts. So the same example with the tree, a branch is a part of the tree. So it's a meronym of the word meaning tree. And Meronomy is good for language learning because many of you have probably seen these illustrations on language learning books where there's like an illustration of a human body or a house or a car. And then you have those little darts that show different parts of the subject. And this is essentially the same thing, only shown schematically. And there is a special type of semantic links that we use to create something we call gradation sets, which is basically a cluster of words that show different degrees of a certain phenomenon. Here, we can see a gradation set that's related to temperature, going from hot all the way to cold. And this is also pretty useful for language learning, but not only that. And since I've told you about semantic links and a bit about synsets, I will just show you a rough outline how they work together in WordNet. So a synset is the smallest unit on which WordNet operates. We don't operate with separate word meanings, but we operate with synsets. Some synsets only contain one word meaning because some meanings don't have synonyms, and that's completely fine. But more often than not, A synset will contain 2, 3, or more synonyms. Some synsets are absolutely huge. They can consist of 40 plus words. But for the sake of brevity, I will use a neat little synset of 2 words, so building and edifice. And this is just one unit, one synset, but it is connected to other synsets. For example, a building is a type of structure, and there are different types of structures. So a bridge is also a structure. So we can see that by following this logical chain of semantic relationships between words and word meanings, we have gone from building to bridge, and our WordNet is already growing by the second. Next, we could think about various things that make up a building. So what does building consist of? So there are rooms, and there are also floors and levels. And on a broader level, a building is also a part of a bigger structure, which is the infrastructure. So this is hyponymy and meronomy. And we could think about different hyponyms and types of buildings as well. So for example, there are schools, churches, skyscrapers. And we could go on and connect different meanings to other different meanings. But for the sake of clarity, let's just imagine that this is our WordNet. But this is not it, since we're only talking about one WordNet of one language. What we can do is interconnect different WordNets of different languages, find equivalent synsets in the target language and connect them. And what we would essentially get are translations, which is great if you're a translator or just a language learner. Here you can see the real life graphs of the Latvian WordNet. Here, for example, is a great example of meronomy. So cars and parts of a car, and then other components that these parts consist of. Or here you can see a neat little example of a gradation set in the form of this purely accidental pentagram under the very center of the graph. And this is what the graphs look like. This is basically a schematic representation of what we've been working on. And this brings us to why are we doing this? Why exactly are WordNets useful? So I've mentioned translation and I've mentioned language learning, but WordNets are useful for so many other different things. For example, natural language processing. For example, sentiment analysis. Instead of having someone read through countless documents and texts, you can train an algorithm and use WordNet for the computer to go through these texts and classify them based on sentiment or topicality. You could use WordNets for automatic word sense disambiguation. So instead of having someone manually go through and distinguish word senses, you could actually train an algorithm to do that based on some basic data from a WordNet. You could do semantic parsing, which in more humble terms is just making natural language, turning it into a machine readable form. You could also use it to represent abstract meanings or train machine translation tools, which is also what has been mentioned today before, and which is also very important. Quality machine translation is actually very hard to achieve. So this could be a probable development in that area. And probably because of the wide applications, there are many different WordNets around the world. The prototype of all WordNets, we could say that Princeton WordNet is the prototype of all WordNets. But since then, there have been so many other WordNets developed for different languages. One of the biggest WordNets so far is the Polish WordNet. But what we can see is that these separate tools are being united into bigger WordNet structures, which combine up to 34 or more languages. And the open multilingual WordNet is also free access and helps to work with more than one language at any given time. There's also WordNets that combine European languages specifically, and there's also an interesting development in the Indian languages section where they have an Indo WordNet, which combines 18 languages spoken across India plus English. And this is a great example how we can break down those barriers between regional languages in larger or smaller countries by using WordNet. And so this is these are just some of the reasons why we are so excited to join this community of WordNets by our own Latvian WordNet, the development of which started in 2020. And my colleague, Professor Lokmane, will tell you more about the Latvian WordNet specifically.
Thank you, Madara. And now I will go on with a closer look at the Latvian WordNet. And here you can see information which was mentioned already. So who is the developer of this project? And it's financed by Latvian Council of Science and the National Research Program, Digital Resources of the Humanities. And our project also has a homepage which can be accessed via this address. The next slide. So the goals of the project. The first one, to create syntax and semantic links for 5,000 most frequently used word meanings. And the list of words was compiled by frequency of use in the balanced corpus of modern Latvian, after dropping particles, function words, and proper words as well. The next, to interlink the Latvian WordNet syntax with counterparts of the Princeton English WordNet. And last but not least, to develop a system of automatic sense disambiguation and WordNet to WordNet interlinking, namely Latvian English. About methodology. There are two possible approaches to creating WordNets. The first is the so-called bottom-up analysis of the language and its lexicography. And the next one is the opposite, to adopt and transfer semantic hierarchy from another language, which is usually English. The former approach is more labor-consuming, but it also results in a resource that is more accurate from a linguistic perspective. Therefore, we have chosen to build the resource based on corpus evidence and linguistic analysis of Latvian, and only afterwards attempt to link it with other language WordNets without expectation that there would be a one-to-one alignment for our syntax. The next one. Thus, the new tool is modeled on the base of the existing dictionary Thesaurus LV, which is also maintained by the Artificial Intelligence Laboratory, and it provides both the initial data set and the technological platform. However, we quickly identified the need to restructure word sense separation in Thesaurus, and this is due to a number of reasons. For example, the fact that Thesaurus contains also quite a few outdated word senses. And also we identified that sense splitting in Thesaurus appears to be rather subjective in many cases and is not based on a clearly stated criteria. I would like to add that the revision and restructuring was done manually. So the next slide. Here we have an editor's view of a Thesaurus entry. So this is how we work. The upper left side shows the list of word senses. The newly added example browser is on the right, and extracts from other Latvian dictionaries for the same entry can be accessed on the lower left side. So information from other dictionaries is used in the working process as well. The next one. Thus, a corpus-based approach, we are sure, enables us to arrive at a more adequate reflection of the relevant word senses. I think one of the most difficult steps in the first phase of our project was to establish criteria for distinguishing senses and ensuring that they were used consistently with the word class, or at least a thematic group. And the criteria we chose are as follows: semantic and syntactic distribution. We also used the method of lexical decomposition and the method of substitution with a synonym. It was also difficult to determine how detailed or fine-grained the senses should be, so that the granularity would be similar across all entries. A second objective was to make entries clearer and more comprehensible to a user of the dictionary. So we tried to achieve two goals at a time, and we hope that we have managed to contribute to the improvement of the word sense inventory of thesaurs as well. The next slide. So here you can see our current achievements in figures, the number of words and senses processed, the number of synsets, and it should be noted that a sense starts to function as a synset when there is at least one link attached to it. The number of semantic relation links, briefly described by my colleague, and the number of words which we considered fully processed up to now. Fully processed means that these words have reviewed sense separation, added corpora examples, senses linked in synsets, and another semantic links, including external links with Princeton WordNet. The next one. And now, a brief survey of semantic links included in the Latvian WordNet with Latvian examples. As the basic structural unit of every WordNet is a set of synonyms or synset, so synonymy is the most important relation between senses. And here we have one of the largest synsets with the meaning sist, to beat. It should also be stressed that synonymy exists between senses, not between words, and the number of the sense in the dictionary is shown with the help of indices here. Then we have two examples of interlingual synonymy between synsets. Spēks un jauda corresponds to the English synset might, mightiness, power, and norādīt, parādīt, rādīt, or the respective meanings or subsenses of these words correspond to the English synset indicate, point, designate, show. The next one. So the next, all the other links exist between synsets as wholes. Here we have two pairs of antonyms, antonymic synsets. The first with the meaning big, and the opposite small, and another quite expanded synset in Latvian with the meaning to be drunk, and its antonym. And as you can see here, the synsets also include expressive meanings, include dialectal words, and also multi-word expressions. The next relation is hyponymy, between a more general and a more specific term. So the hyperonym is the general term. Here in the example, it's the synset celtne ēka, and it's hyponyms or more specific terms. Yes, the next one. The next relation is meronymy, relationship between a part and a whole. The whole is called a holonym, like likumdošana in the first example, and its meronyms or parts are different types of documents. And the second example, the holonym ziets, and its meronyms show the parts of ziet. the next one. And last but not least, we also included gradation sets in the Latvian WordNet, which means that they express different values of the same attribute. For example, different intensity. And most often, gradation sets refer to adjectives like gigantisks, milzīgs, and so on. But it may also include different parts of speech, for example, nouns and also some verbs. And here you see also a gradation set with the general meaning rain, lietus, showing different, let's say, levels of raining or intensity of raining. Thank you. And now we come to the last slide regarding our further perspectives. So our goal is to create the so-called 3-in-1 language tool, which would combine defining dictionary, thesaurus, and multilingual dictionary. And which is also important, it will be a free access language tool. Another perspective, to develop an automatic word sense disambiguation system based on the manually created data. So this goal was already mentioned before. We consider it to be a very important one. Of course, we hope to be able to continue in expanding the inventory of processed words and word senses, because it's also very important aspect how many words and how many senses are included in a WordNet, and of course integrate Latvian WordNet into open multilingual WordNet. And a few selected references, and thank you for your attention and your questions. We will answer with pleasure.